Okay, so I do want to go through the two more examples here, just to solidify, solving for inequalities. And in this particular example, it says, solve this to be greater than or equal to 1. And the thing is that we need to make sure when we solve these that we are always comparing it to 0, right, for our sign. So if it's not equal to 0, we need to set it equal to 0. And so in order to do that, so I'm going to rewrite this as x plus 2 over x minus 4 minus 1 is greater than or equal to 0. Now, that 1 that we have, I need to subtract it from the given expression. And the thing is I need to make sure it's a common denominator, which would be like x minus 4, since this one really just doesn't have a denominator. It's like a 1, right? So what I need to think about is this is x plus 2 over x minus 4 minus basically 1 of the x minus 4s over x minus 4s. And again, just kind of going back and reminding yourself like where I would have got, I would have gotten that from. So I really, obviously this 1 tells me what my coefficient was, but then, the x minus 4 over x minus 4, that's just a fancy 1. So I needed that common denominator. Okay, so then, then I go ahead and say, okay, that's x plus 2 minus x minus 4. Don't forget your parentheses. All over, since it's the common denominator, x minus 4 is greater than or equal to 0. And now I can actually distribute that negative. So x plus 2 minus x, and then plus a 4 over x minus 4 is greater than or equal to 0. Now the x's happen to cancel. So come up to here. We get 2 plus 4, you get 6 over x minus 4 is greater than or equal to 0. So there's really only one critical value here. There's only one time when the fraction's numerator or denominator is 0, and that happens in the denominator when x is 4. So I'm going to go ahead and draw a number line and pick 4 as my boundary. And if you pick something that's bigger than 4, okay, thank you. If you pick something that's bigger than 4, let's say 5, and you put it into your function, 6 over 5 minus 1, 5 minus 4 is 1, 6, which is 6, which is positive, which means I know that this region is positive. And you could do one of two things. You could pick something that's less than 4 and see that you get a negative value, or realize that the multiplicity of this, there are an odd number, so it switches signs, so that's negative. So now I want to make sure that I pick the positive, right, where it's greater than or equal to 0, which is this region. Now, you have to be really careful because initially you might think, oh, it's 4 to infinity, because I see for a fact that it's greater than or equal to 0. But the thing is that that 4 would have given a 0 in the denominator. So it's undefined at that instance. We have to sort of override that and say, wait a minute, in this particular case, it has to be open-ended 4 to infinity. Okay, so that's just really one small caveat there that, you have to really, really be careful about that endpoint. Okay? Now, the next example, just to kind of go through just practicing finding a common denominator, so we'll set this one up. So again, I need to set it equal to 0. So I'm going to have 1 over x plus 3, and then there's the minus 5 over x plus 2, and then adding 2 plus 2 is less than or equal to 0. So you want to compare it to 0. And then in terms of like a common denominator, like the common denominator would be all 3 of those factors, and the one is kind of like irrelevant. So the first one, like 1 over x plus 3, we would need to multiply that by, I keep picking the wrong spot there. X plus 2 over x plus 2, and then I could say minus 5 over x plus 2, and then it needs the x plus 3. So there's that, fancy 1 multiplying by, and then plus 2 over 1, and it needs both. right? Because it didn't have any of them. So, oops, put that color right there. So it has x plus 3 over x plus 3, and then x plus 2 over x plus 2 is less than or equal to 0. Okay, so now I can actually, multiply. So I have x plus 2 in the top. Distributing that 1, not going to change anything. Minus 5 times x plus 3. I'm going to have to be really careful when I distribute. Plus 2 times x plus 3. X plus 2 all over x plus 2 times x plus 3 less than or equal to 0. And again, I think I mentioned this. You definitely want to distribute. So I've got, so I've got. I might come over here actually to have a little more space. So I've got x plus 2 minus. If I distribute this, it's a minus 5x plus, or sorry, minus 15. Be careful. I almost did what I was going to try to warn you. Plus, and then it's going to be 2. And I go ahead and distribute inside first. So x squared plus 2x plus 3x is plus 5x. And then 3 times 2 is 6 if I factor, or sorry, reverse factor, or sometimes you think of it as FOIL, over x plus 2, x plus 3, and then go ahead and distribute the 2. And I can, x minus 5x is negative 4x, 2 minus 15 is minus 13, and then we can say it's plus 2x squared plus 10x plus 12 over x plus 2 and x plus 3. Okay. And then maybe I just simplify that top. And we probably won't go through the whole thing because I think you get the idea here. And to be, oops, sorry, my hand keeps hitting it. To be honest, it won't be as of a complicated problem. Like, I just want to show you finding that common denominator. 10x minus 4x is plus 6x. And then negative 13 plus 12 is negative 1 all over x plus 2 times x plus 3. So it would be factorable on the top. You'd find your zeros. We know negative 2 and negative 3 are zeros, and you go from there. I think the key is finding that common denominator. And if I'm thinking in terms of the quiz tomorrow, that it would be more like example 5, where there's just 2 factors, like one has a rational function, one doesn't, as opposed to a function has 2. So, okay. So, again, just as extra practice, those inequalities, graphing those sign charts. So, take a look, see how you do, and let me know if you have any questions.